All right, so what is the difference between a single blind test and a double blind test? They both use a placebo, right? It just the difference is which one, who knows which patients or the subjects are getting the placebo and which ones are not. Okay, so in a single blind test, the patients do not know to which group they belong. Okay, so the two groups are typically called the control group and the treatment group, right? But evaluators, often doctors, do know, of course, which group has which patients and so on. In a double blind test, the problem is a single blind test, evaluators can be influenced by their knowledge on which patients belong to which group, because after all, the evaluators are human too, and if they think that a certain patient is supposed to be getting better with the active ingredient, then the evaluator may give higher scores or whatever. In a double blind test, which is designed to avoid such a bias, neither the patients nor the evaluators know to which group the patients belong. Okay, and this is again to avoid some kind of a bias that is possible, right? So it is better to not to let the doctors or evaluators know who belongs to which group, especially if the assessment or evaluation is subjective, such as for antidepressant or itchiness or the mood or something. Okay. Good. Number 17, in the normal distribution, what is the probability that the value is below the mean? Now, do you remember what the normal distribution is? I say the normal distribution. Actually, there are many normal distributions, but there's only one called the standard normal distribution, right? Right. But in any normal distribution, the mu, the mean is the middle. So below the mean, that's 50%. Okay, so it's 0.5. or 50%. What is the probability it's above the mean, but not within one standard deviation of the mean? So we're talking about this situation here. This is the mean, right? And then one standard deviation above the mean is here. So what is the probability that the value is above the mean, but within one standard deviation of the mean? Now, remember, if you had both sides, that's 68%. That's one of these things that we studied in the section, in the last section of the chapter 5. And there was a rule called the empirical rule. Sometimes it's called the 68, 95, 99.7 rule, right? So the 68% belongs to the interval within one deviation of the mean. But in this case, we're talking about above the mean. So we have to just consider half of this. So the answer is 34% or 0.34. Okay, again, that's because it's half of that. By the way, if you didn't know that, or if you forgot that, I will be providing you with at least one of these things. Okay, and so you can tell here, this is exactly the area I was talking about. That's 3413 in the decimal. 1.00 also, this is not the one. 1.00 also can be found there, and so the probability is 0.3413. So 34.13% is a more precise answer to that question that we were working on. 34.13%. More precisely using a table, right? Okay, so that's the answer to that. Number 18, to conduct a student opinion survey, identify the type of sampling used here. We picked every 100th name from a comprehensive list of all students at this college. Because it's very systematic, every 100th, it's called systematic sampling. Pick 50 males and 50 females. That is, you're stratifying the student body. So this is stratified. sampling. Okay, and then pick 100 personal friends. That's convenient. So that's convenience sampling. Okay, not the best way to choose your unbiased sample if you pick your own personal friends, because they all have this one thing in common, that the fact that those are your personal friends, and I am sure there is bias involved in that. Number 19, to find how many hours American people watch TV every week, we choose 1,000 Americans from all over the country. That's good, not just on the local, in the local region, and discovered that on the average, they spend about 41 hours watching TV each week. What is the population? Population is the group of people or things that you are studying. Okay, it's clearly written here that you are not just studying 1,000 people. You are studying, or you want to find out something about the American people. So it's the American people. Okay. Usually, this population is identified either explicitly or implicitly in your question. Okay, like right here, it's very explicit. What is the sample? Sample are the 1,000 people chosen. The sample size is exactly 1,000 in this case. What was the parameter? The parameter is the real value you are looking for, right? And so the parameter is the real average number of hours of TV watching. Okay, so you will collect the information. In fact, you'll get 1,000 different values. You take the average, and that average, by the way, is not the real answer, right? Because you will never know this real answer, like how many hours does the typical American person watch TV, but that is the parameter, which will probably never be found. Okay, so it is the true average number of hours the Americans watch TV every week. No one will ever know that. But the statistic is the estimator for that. That's the 41 hours. This is the sample mean in this case. It's based on those 1,000 values you obtained. You found the sample mean, and that is the statistic in this situation. Number 20, if you draw a card from a deck of cards, standard deck of cards, and then you roll a die, okay, so you have this stack of cards, and you roll a die, what is the probability that you get a spade card and a 1? Okay, so now that's supposed to be a spade. Okay, now you know that these are independent, right? Because the picking a card has nothing to do with the roll of a die. They are independent of each other. They do not influence each other. So the probability of this AND statement is simply the product of the two probabilities. Probability of getting a spade is 1/4, because a quarter of the deck of cards is a spade. By the way, this is also the same as 13 divided by 52, 13 being the number of spades and 52 being the total number of cards. And then you multiply this by the probability that you get a 1 on the roll of a die. And the answer to this question is 1/24. Okay, and you can multiply because these are independent events. All right, so we will start the next segment at number 21 of this practice test.